This iconic warp drive scene from the hugely popular sci-fi series Star Trek, beloved by countless fans, might be remembered in the near future as a vision that predicted the future. In the 16th century, the total human population on Earth was about 580 million. 2 centuries later, in the 18th century, it reached 1 billion. Another 2 centuries on, by the 20th century, it had grown to 2 billion. And by the 21st century, it skyrocketed to 6.1 billion. And as of January 15, 2022, the world's population has surpassed 8 billion and is still increasing rapidly at this very moment. According to UN projections, the global population will reach 9.7 billion by 2050 and 10.4 billion by 2080. The problem is, Earth's resources are finite. Limited resources inevitably lead to competition, competition breeds conflict, conflict fuels hatred, and hatred ultimately leads to war. And today, humanity possesses weapons, powerful enough to destroy each other many times over. If we fail to solve the resource crisis caused by population growth, humanity's self-destruction seems inevitable. Fortunately, there is a way to sustain this population growth while solving the resource problem: tapping into resources beyond Earth. If we can mine resources from other planets and access what's practically unlimited, we could avoid our foretold doom and achieve unprecedented progress. But there's one huge obstacle: the sheer distance between planets. Even the Moon, Earth's closest neighbor, is about 385,000 kilometers away, over 9 times the circumference of the Earth. When Neil Armstrong made his historic first steps on the Moon, it took Apollo 11 4 days and 7 hours to get there. Space, where distances are measured in light years, is so vast that even if we could travel at the speed of light, it would still take thousands or even millions of years to reach other stars, making interstellar resource mining, or even just arriving, virtually impossible. So, for us to achieve interstellar travel, we would need a technology capable of moving faster than light. All objects with positive mass cannot travel faster than the speed of light. However, according to this cornerstone of modern physics, moving faster than light would mean time flows backward, breaking causality. So far, no material particle faster than light has ever been discovered. Naturally, this meant there was no way for humanity to surpass light speed, making interstellar travel seem forever out of reach. But surprisingly, a solution had already been imagined long ago. Celebrating its 59th anniversary this year, Star Trek is set in an age where interstellar travel is routine, and humanity boldly explores and pioneers new frontiers. Humanity in Star Trek achieves interstellar travel thanks to the warp drive, a propulsion system that allows starships to travel faster than light. Star Trek has incredibly detailed and plausible lore about how this warp drive works. In reality, when matter and antimatter meet, they annihilate each other, in a reaction so powerful that just 1 gram of positrons produces almost 3 times the energy of the atomic bomb dropped on Hiroshima. The starship's warp core uses a fictional element called dilithium, which prevents this annihilation when antimatter comes into contact with it. Inside the warp core, massive energy is generated by mixing deuterium and its antimatter counterpart, antideuterium. This energy charges the ship's warp coils. Once charged, the warp coils create a huge warp field that surrounds the ship in a warp bubble, contracting space in front of it and expanding space behind it. Enveloped in this warp bubble, the ship is naturally pushed forward by the expanding space behind it. Because the contraction and expansion of space happen on such a massive scale, and so rapidly, warp-capable starships can traverse vast distances between stars in an instant. Simply put, warp travel is like folding space to move through it. The space in front of the ship folds inward, while the expanded space behind pushes it forward. To an outside observer, this bizarre method of travel makes it look like the ship stretches and then suddenly zips away. Even the crew on board can see the landscape around them distort as space contracts and expands. This seemingly absurd sci-fi technology took a dramatic turn when one scientist began to take it seriously. In 1994, Mexican theoretical physicist Miguel Alcubierre proposed the Alcubierre drive, a theory that makes faster-than-light travel possible without violating the laws of physics. The Alcubierre drive uses a warp bubble to compress space in front of the ship and expand it behind. remarkably similar to Star Trek's warp drive. When this theory was first presented, it was dismissed as pure fantasy by most of the scientific community. But when other scientists worked through the math, they were shocked. If a ship traveled this way, the space around it would move, not the ship itself, so it wouldn't break the rules of relativity. Further research and cross-verification revealed that what seemed like pure fantasy is actually the most realistic faster-than-light theory we have. While a faster-than-light object does not exist, faster-than-light phenomena do. One example is the Cherenkov radiation, the blue glow seen when radioactive particles move through water faster than light does, in that medium creating an optical sonic boom. Another example is quantum entanglement. No matter how far apart, two entangled particles instantly affect each other's states, a phenomenon faster than light that still obeys physics. So, if we travel as a phenomenon, not as matter, breaking the light-speed barrier doesn't contradict physics. Einstein's theory places no limits on how or how much space-time can be warped. In fact, right after the Big Bang, the universe expanded at about 10 to the 50th times the speed of light, proving that space-time itself can move faster than light. If we can master this, we could theoretically compress or ride space-time waves. Like a surfer riding an ocean wave, a starship caught in a space-time wave is moving as a phenomenon. Its actual speed is slower than light, so no laws of physics are broken. Warp travel is no longer just sci-fi fantasy. Earth is exposed to countless disasters, and the planets in our solar system are unsuitable for human habitation. That's why we must explore exoplanets for new homes. This is part of humanity's growth and evolution. Recognizing the potential of faster-than-light travel between stars, NASA established the Advanced Propulsion Lab EagleWorks to study the Alcubierre drive in earnest. They even discovered that high-energy lasers might be able to warp space-time. If so, the Alcubierre drive could theoretically make a trip from Earth to Alpha Centauri in just 2 weeks. In 2014, concept art for the warp-capable starship ISS Enterprise was revealed. According to NASA, the two large ring structures surrounding the ship are the Alcubierre drive. The design is inspired by the USS Enterprise from Star Trek, a vision of what interstellar travel could look like. Of course, there are still massive hurdles to overcome. Just like Star Trek uses antimatter to generate vast energy, the Alcubierre drive would require 500 kilograms of exotic matter to create a warp bubble and distort space-time. Exotic matter with negative mass remains purely theoretical. While the Casimir effect creates a tiny force between two metal plates in a vacuum that hints at exotic matter, the quantity generated is only a trillionth of what we'd need. Far from practical. A new hypothesis in 2021 suggested that space-time might be warped near the event horizon of a black hole without exotic matter, but this approach requires us to get dangerously close to black holes. Yet no one can deny that the Alcubierre drive is still the most realistic faster-than-light theory we have. In December 2021, DARPA, the U.S. Defense Advanced Research Projects Agency, accidentally created a tiny warp bubble while studying the Casimir effect, proving the idea isn't just wishful thinking. In May 2022, researchers from NASA and SpaceX who had studied the Alcubierre drive formed the Limitless Space Institute and continue to dedicate their lives to interstellar travel. Still, skepticism remains. A major issue is that when a starship moving at warp slows down, particles caught in the space-time wave could be released as a massive burst of energy, destroying everything ahead. Just like in Star Trek strictly prohibits dropping out of warp within a star system. Even if we solve the problem of generating large amounts of exotic matter, storing it safely is a whole other challenge. Countless other hurdles remain, making the Alcubierre drive's feasibility uncertain for now. Yet humanity continues to pursue the infinite frontier by every possible means. No nationality, race, religion, or interest stands in the way. Only pure human aspiration drives us forward. About 8,000 years ago, humans invented boats to cross the seas. About 120 years ago, we invented airplanes to conquer the skies. About 60 years ago, we built spacecraft to reach the stars. So when will humanity finally roam the cosmos through warp travel? This was Midnight Journey.